Number 9. Two figures are shown below. We've got this one and this one. Which statement about these figures appears to be true? So all we're doing is we're checking these and seeing if they're right or not. They have a total of 5 acute angles. Okay, this says total. That means I have to check all of the angles and see how many they have of each kind of angle. Let's take a look. All right, this first angle is not too big, not too small. It fits just right. So this is a right angle. Hey, so is this one. So is that one. Now this one doesn't fit right. This one's a little bit too big. The angle is too big. That means it's obtuse. That angle is also too big. And if it's too big, that means it's obtuse. Okay, let's check the next one. Okay, I've got an angle that's too small now. My sticky note won't fit. Means it's acute. I've got another one of those angles that's too big. I've got another angle that's too big. Another obtuse angle. I got another one of those angles that fits perfectly. It fits just right. And I've got another angle that's too big. So another obtuse. So if I take a look at all my angles here, I've got one acute angle. I've got 1, 2, 3, 4, 5 obtuse angles. And we've got 1, 2, 3, 4 right angles. Answer choice A says they have a total of 5 acute angles. I only found one. B says they have a total of 4 right angles. Yeah, I measured them and I found 4. C says they have a total of 4 obtuse angles. That's really close. But when I measured the obtuse angles, I had 5. D, they have a total of 3 right angles. They would if I didn't look at the second. If I didn't look at the second figure that they gave me, I would have 3. But since they give me 2 figures, I don't have 3 right angles. I have 4. So my answer is B. They have a total of 4 right angles. Question 10. Which of these could not have 2 pairs of parallel sides? They said not, so next to all of my answer choices. I'm going to set it up so that way they can't trick me. Yes and no. Yes and no. Yes and no. Yes and no. And again, they're asking me about shapes, but they don't give me a picture. They don't give me a picture, I'm going to make my own. Trapezoid. Square. Rhombus. Parallelogram. And they're looking for 2 pairs of parallel sides. Trapezoid. can have one pair. Got the top and the bottom here. But if I check the left and the right side, I can see that they would run into each other up here. So, no, a parallelogram cannot have two pairs of parallel sides. A square, yeah. The top and the bottom, the left and the right. A square can absolutely have two pairs of parallel sides. A rhombus. This side and this side are parallel. This side and this side are parallel. A rhombus can absolutely have two pairs of parallel sides. A parallelogram. It's in the name. The left and the right. The top and the bottom. Two pairs of parallel sides. So out of those four shapes, there's only one of them that cannot have two pairs of parallel sides. That is the trapezoid. Trapezoid can only have one pair of parallel sides. Number 11. Which statement about rectangle QRST appears to be true? Okay, so here's my rectangle, QRST. They want us to check what they're telling us about this rectangle. Line QR is parallel to line QT. Parallel means my lines never touch. Lines QR and QT touch right there. They cannot be parallel. B says line QR, top line, is parallel to line TS. There's TS. If I stretch those out, QR and TS, they don't run into each other, and they never will. C says line QR, top line, is parallel to line QS. QS is right here. It's my diagonal line. And again, you can already see them touching right there in the corner. If they're supposed to be parallel, they never, ever touch. D, line QR is parallel to line RS. RS is right here. And they're touching right there. There's only one pair of lines that they mentioned that would be parallel, and that would be line QR, my top line, and line DS, my bottom line. Number 12. Look at the figures below. Okay, four shapes. Which statement about these figures appears to be true? So we have to see something that is true about all of these shapes. They are all parallelograms. Again, to be a parallelogram has to have four sides. All of these shapes have four sides, but to be a parallelogram, they also have to have two pairs of parallel sides. Figure number 1 is a parallelogram, for sure. Got two pairs of parallel sides right there. But figure 2 is not a parallelogram. If I look at the top and the bottom, and if I stretch them out, it might take a while, but they would run into each other. So they are not all parallelograms. G, they all have at least one obtuse angle. All right. Well, if I check, I could see that some of them have obtuse angles, but I also notice that one of the shapes is a rectangle. We've said it a few times on this test. A rectangle and a square both have to have 4 right angles. That rectangle cannot have one obtuse angle. H, they all have at least one right angle. Okay, that one I could check because I know for a fact this has all right angles. See, I'm going to check the first shape. Well, that angle's too big. That means it's obtuse. This angle is too small. Means it's acute. That angle is too big. That means it's obtuse. This angle is too small. That means that it's an acute angle. I don't have to keep checking the other ones because figure 1 doesn't even have one right angle. So it can't be H. J says they are all quadrilaterals. The only thing a shape has to do to be a quadrilateral is have 4 sides. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Every single one of those shapes has 4 sides. And if it has 4 sides, that means it is a quadrilateral. Kylie, make sure you're working. We have our last question. A landscaper installed landscape edging around a student courtyard. He had 32 pieces of edging, and each piece was 9 feet long. Which equation can be used to find F, the total amount in feet of edging installed by the landscaper? Got my question mark and my question word. Which equation can be used to find F, the total amount in feet of edging installed by the landscaper? So they're looking for F. What does F mean? Feet of edging. If I read my question here, they tell me that they had 32 pieces of edging and that each piece was 9 feet long. Since they use the word each, that should tell me I should either multiply or divide. So here's one piece of edging. It's 9 feet. The landscaper did not just use one piece. He had to use more than one piece. There was another piece, another piece, another piece. Eventually, he used 32 pieces. And every single time he went and added another piece of edging, it would get longer and longer and longer and longer, which means my number is going to go up. My number is going to go up, that means I need to multiply. If I wanted to find how many feet all together, I should have done 9 times 32. Or, because it's multiplication, 32 times 9. If I look at my answer choices, there is only one answer choice that has multiplication. Answer choice C.